Hello, my name is Jorge Jordan and I'll be talking about hydraulic fracturing, also known as fracking. A simple way to describe fracking is that it's a method of blasting high-pressure jets of water into underground gas and oil deposits to flash out the Earth's hard-to-harvest fossil fuels. To go into a little bit more detail, fracking involves tapping shale and other types of rock formations by drilling a mile or more below the surface. After reaching the desired depth, the drill will gradually turn horizontally to continue drilling for several thousands of feet. A single drill can accommodate more than one well. Once the well is drilled, it is cased and cemented, and small perforations are made in the horizontal portion of the well pipe. Then, a mixture of 90% water, 9.5% sand, and 0.5% chemicals are pumped at high pressure to create microfractures in the rock that are held open by the grains of sand. Additives help reduce friction and pipe corrosion. As you can see in the picture to your left, starting at the top, fracking starts out with a long vertical hole called a wellbore that is drilled down through layers of sediment. When the well reaches 2,500 to 3,000 meters, the horizontal drilling process begins. There the drill turns 90 degrees, drilling several thousand feet, approximately 16,000, through a compressed layer of shale. Then a perforating gun is lowered and fired, creating a series of small inch-long holes through the well's casing into the rock layer. 5 months later, the well is ready for fracking to begin. Fracking fluid is then pumped down into the well at enormous pressure that cracks the shale rock where the inch-long holes were, and the gas or oil start to escape through a pumping and flushing process. Picture number 2 to your right is a schematic overview of a typical shale gas well, showing the configuration of casing pipes and cemented intervals. As you can see, many shale gas wells are deviated from the vertical into near horizontal orientations as they enter the targeted shale strata. Groundwater aquifers are typically located in the shallow surface, whereas shale gas reservoirs are located much deeper. The integrity of the casing and adjacent cement is critical in preventing contamination of groundwater with drilling mud, fracking fluid, or released natural or gas. In the history of fracking, its birth can be tracked to 1862, when during the Battle of Fredericksburg in Virginia, a Civil War veteran, Colonel Edward A. L. Roberts, saw someone firing an explosive artillery into a narrow canal that was obstructing the battlefield. This method was called superincumbent fluid tamping. Edward Roberts came with the idea of packing a torpedo in an iron case containing 15 to 20 pounds of gunpowder. The case was then lowered into the oil well as close to the oil as possible. The torpedo was connected to the surface with a wire, and once it was in position, it would explode and the borehole would be filled with water. On April 26, 1865, Roberts received his patent for improvement in exploding torpedoes in artesian wells. His technology development was known as the exploding torpedo, of course. With his invention, Roberts increased production by 1,200% in some wells. He would then found Robert Petroleum Torpedo Company, which charged, check this out, $100 to $200 per rocket, plus 1/15 of profits generated by the product. Real commercial hydraulic fracking innovation did not come until the 1930s, when drillers used a non-explosive liquid called acid instead of nitroglycerin. It helped wells being more resistant to closing and increased productivity. The first experiment of hydraulic fracturing happened in the 1940s, 1947 to be exact, and the trial was done by Floyd Ferris of Stanoland Oil and Gas. This experiment occurred in the Hugoton gas field in Grant County, Kansas, where 1,000 gallons of naphthenic acid and palm oil, also known as napalm, and sand were injected in a gas-producing limestone formation at a 2,400 feet depth. Once the gasoline and sand were injected to stimulate the flow of natural gas from the limestone, then a jailbreaker was injected. This experiment failed to produce a production increase, but it marked the beginning of fracking, of modern fracking, I guess I should say. In 1949, two commercial experiments, one in Oklahoma and another in Texas, by a company by the name of Halliburton, fracking quickly became commercialized. By the first year of operations, 332 oil wells were treated with crude oil, gasoline, and sand, increasing production by 75%. In 1953, water started being used as a fracking fluid, and by 1968, fracking was being used in oil and gas wells across the US, though its application was limited to the less difficult geological formations. In the 1970s, the U.S. Department of Energy and Gas Research Institute, in partnership with private operators, took on the challenge regarding the difficulty for accessing the hydrocarbons from a shale rock. Techniques such as horizontal wells, multi-stage fracturing, and slick fracturing accomplish natural gas production from shale. It was not until later in between 1981 and 1999 that a company called Mitchell Energy and Development experimented with the techniques developed in the 1970s. Commercial success came when they discovered that slick water, a low viscous mixture, could be rapidly pumped down a well to deliver more pressure than ever before to the rock. By 2002, fracking spread and was being done by many companies in Texas, Oklahoma, Arkansas, Louisiana, Pennsylvania, West Virginia, and the Rockies. It's good to know that even though fracking is over 100 years old, like many technologies, it has been innovated and renovated over long periods of time. But what enabled the oil and gas industry to extract oil from shale rock over the past 10 years was higher prices. If it weren't for higher oil prices, the capital investment needed in the oil and gas sector wouldn't have occurred, and US oil production would have continued to decline as it was doing. The International Energy Agency estimates that as of this year, the US will account for a third of new oil supplies. In this map of the US, you can see in the salmon color, those are the current shale plays, where you see red lining, those are the youngest and the shallowest. The ones with blue lining that are not many, those are intermediate depth and intermediate age. Um, Purple lining would be the deepest and the oldest. The yellowish color are the prospective shale plays. And then you have on the, I guess, violet color or light pink would be basins that are yet to be exploded. In Europe, fracking is not as popular as in the US because Europe's geology is much more complicated. Shale is buried deeper underground and it's 3.5 times more costly than in the US. Here you can see that France has the lead, then Norway, Sweden, Denmark, Netherlands, the UK, and then Germany. It's Considering the environmental costs that I will be talking on the next slide, it's very weird to see that Norway has such a big piece of the pie. When it comes to the environment, by far the most serious concern is that of groundwater contamination. The risk comes from the injected fluid and released natural gas. Most water contamination from fracking has been associated with poor well casings under cement or from leakage of fluids at the surface. Chemical additives are quite dangerous, and due to the interest in keeping the chemical formula that mixes with the water a secret for competitive advantage, there are some companies, not in the US because of regulations, but there are some companies in other countries that have no legal obligation to declare the exact composition of the mixture. So in any case of an accident, you don't really know what's going to contaminate the water and the land. There are also blowouts. Uh, Surface and subsurface blowouts have occurred in Colorado, Texas, Ohio, and Pennsylvania. It's when the fluid injected into the well does not fracture the rock as it's intended, and the fluid will leak into other permeable pathways. Water as a source is quite worrying. Um, the vast volumes of water required for fracking vary, and it's estimated between 90,000 and 13,500 million liters per well. So, in between 23,000 and 35 million gallons. The amount varies due to the well's lifetime, that can go from days to years. Regarding the fate of the fracking fluid, it has not been possible to decontaminate the water that is used for fracking, and it's been tried, but it's very costly and energy demanding. So new fluids that are free from chemical additives are being developed. Emissions to the atmosphere, like methane gas and vapor from the fluid used, can cause serious greenhouse emissions, even worse than coal. In 2016, a 5.6 magnitude earthquake on the Richter scale was recorded in Oklahoma. It was the strongest ever recorded. Though the earthquake was not caused by fracking itself, but by the injection of fracking wastewater, other waste, and production waste into the subsurface, is considered that fracking, is involved. It is thought that it reactivates nearby pre-existing faults by upsetting the subsurface pressure regimes that keep the faults closed. In any case, it's important to have in consideration that fracking is not the cause of induced earthquakes, but the wastewater associated to fracking is. Personally, I fail to see what's the point in keeping gas and oil if we have found other sources of energy, especially when it comes to polluting water, which it has in many communities in the U.S. So, well, that's my personal opinion. Thank you very much. I hope you enjoyed it. I hope I've, you know, learned something new, and thank you. These are my sources.